Today we begin solving two-step equations, which begins chapter 10. Alright, so to solve two-step equations, two things you need to do. Step 1, undo the constant first. Remember, your constant is the one without the variable, and you do that by adding or subtracting. And step 2, undo the coefficient by multiplying or dividing. The coefficient is the number that has the variable with it. So first thing you want to do is undo the constant by doing the opposite. And then second, undo the coefficient by doing the opposite, which would be either multiplying or dividing. So in the first one, it says Joe is paid a weekly salary of $520. He is paid an additional $21 for every hour of overtime he works. This week, his total pay, including regular salary and overtime pay, was $604. How many hours of overtime did Joe work? So in this one, we'll have to set up the formula first, set up the equation first, which would be that starting weekly salary of $520. And then you will add the overtime pay, which is $21 times how many hours he worked. We don't know that, so we're going to use the variable x. And that will give us a total of $604. So our equation is 520 plus 21x equals 604. Now to solve this, you follow the two steps we just said. So first we want to get rid of the constant, and the constant is the one without the variable, and we're going to do that by doing the opposite. Since this is positive, you know to do a minus 520, so that it cancels out. And on this side, we're going to do the same thing. Whatever you do to one side, you do to the other. So these will cancel out, and you're left with just 21x. And on this side, you subtract, and you get 4, borrow to make that 10, and an 84. So now we have 21x equals 84. And remember the second step, undo the coefficient. Since this says 21 times x, you undo it by dividing by 21 on both sides. So 21's cancel out, and I'm left with just an x. And over here, when you divide 84 by 21, you get 4. So your answer would be 4. So again, your steps. Step 1, undo the constant by doing the opposite. Step 2, undo the coefficient by doing the opposite. And you have your answer. If you ever want to check your answer, just plug your answer back into the equation and see if you get this answer. So if we was to plug the 4 back in, you'll do 21 times 4, which is 84, plus 520 to get 604. All right, I want you to go ahead and try this problem here. On this one, you should get P equals 32. And try this one. Well, I'll do this one with you, because you have to remember the decimal rules as well as your integer rules, since we're dealing with negatives now also. But the steps don't change. We still want to get rid of your constant first, which is minus 1.7. We undo that one by adding 1.7 to both sides. 1.7. On this side, they cancel out. And over here, remember that you're adding decimals. You line up your decimals. You end up with 15, carry the 1, 3.5. So we have now negative 2.5m equals 3.5. And in order to undo negative 2.5, since it's multiplying, you want to divide by negative 2.5 on both sides. So when we do it, top in, bottom out. So we're dividing by decimals. You have to remember your decimal rules. If you have a decimal on the outside, you need to move it so that it goes all the way to the right. So we'll just move it one time. Whatever you do to the outside, you do to the inside. Move this decimal over here, and then you can bring it up. So now we have 35 divided by 25, and we do that. 21 goes into 3 0 times, but it goes into 35 once, which is 25. We subtract, we have 10. Now we don't want to have a remainder, so you get your 0 and bring it down. 25 goes into 100 4 times. So your answer would be 1.4, but you have to remember positive divided by negative is negative. So your answer is negative 1.4. And again, if you want to check that work, just plug it in. All right, so I want you to try this one on your own. And on this one, you should get x equals 3.5, 3 1/2. Okay, so now we're going to begin solving two-step equations. Now in this one it says k plus 4 divided by 9 equals 6. Notice that we said the k plus 4 first. So in this one, the k plus 4 is together and we need to get rid of this 9 first. So in this one, you undo divided by 9 by multiplying by 9 on both sides. That way they cancel out and you're left with k plus 4 equals 54. Now we can undo that plus 4 by subtracting 4. On this side, they cancel out and we're just left with k. On this side, it equals 50. So your final answer, k equals 50. If you plug that in, 50 plus 4 is 54 divided by 9 will give you 6. All right. I want you to try this one on your own. On this one, a equals 87. 87. All right, time to step it up a little bit more. Now we're going to be solving multi-step equations. On this one, you're solving equations that contain like terms. The first thing you want to do is combine those like terms. Second thing is undo the constant first, just like before. And the last thing is to undo the coefficient. So same thing, except for there's one thing you want to do first, which is to combine your like terms. Your like terms are the ones that have the same variables. So 2x and 5x all have x's. So those are like terms. As well as the ones that do not have a term at all, such as plus 4 and negative 8, or minus 8, sorry. So constant, since they do not have a term at all, they will be like terms as well. So in this one, when we combine our like terms, you'll do 2 plus 5x. 2 plus 5 is 7x. And then we have a positive 4 minus 8, which will give us a negative 4. You have to remember your integer rules, and then you just bring down equals 24. Now that looks like something we've done before. So again, you do your like terms first. Now we can undo the constant, which is minus 4, by doing plus 4. These will cancel out, and I'm left with 7x on this side. Over here I have 28. And our final step is to undo the coefficient. Since it says 7 times x, you want to divide by 7, in which x equals 4. And just like usual, if you plug that 4 in to this equation, you should be able to get 24. All right, I want you to try this one on your own. on this problem, you should get D equals 2. And also try this one. On this problem, you should get H equals 9. All right, now we have to be able to do the same things when it comes to fractions. When it comes to these fractions. Now, everybody loves fractions, so just make sure you're paying attention because the same rules apply. You're just adding them in. Now, since we are adding and subtracting fractions, we know that we have to find a common denominator. Now, a lot of times, if you have the ability, you can just look at the numbers and determine what the common denominator is, which in this one would be 12. All of these numbers, 3, 4, 6, and 2, goes into 12 evenly. So the first one, it says plus, and over here, minus, and that one says equals. Now we just got to figure out what the top numbers are. And in order to get from 3 to 12, you multiply by 4. So when you multiply 2p by 4, you get 8p. Over here, times 3. Times 3, you get 3p. Times 2. 1 times 2 is just 2. And then times 6. 7 times 6 is 42. Now, here's a good trick. Since we know we all have the common denominator in which we'll be able to just add and subtract accordingly, we could just focus on the top part. So we're only going to worry about the numerators. So I'm going to rewrite it as 8p plus 3p minus 2 equals 42. Now I can combine my like terms. 8p plus 3p equals 11p minus 2 equals 42. And now I can undo my constant by adding 2 to both sides. I'm going to bring it over here, in which the 2's cancel out, and I'm just left with 11p. 42 plus 2 equals 44. And my last step is to divide by 11, in which p equals 4, which will be your final answer. So if you plug in this 4 into each of these p's, your final answer will be 7/2. So in this one, a good trick is to find your common denominator, and then when you have all the same denominators, only look at the top numbers, only look at the numerators. All right, so try it with this one. In this one, you should get y equals 2. All right, here's a money application problem that I want you to pause the video and read. See if you can set up the equation and then solve for it. On this one, whatever variable you get, such as x, it should have been $12. Your final answer, her bill was $12. Her original bill was $12. All right, good idea, bad idea.
It's time for another good idea, bad idea. Good idea. Feeding stray kittens in the park. Bad idea. Feeding stray kittens in the park to a bear.